All right, welcome to 5-2. In 5-0, we covered solving linear equations, systems of equations. In 5-1, we covered solving quadratic and nonlinear systems graphically. And in 5-2, we are covering solving those nonlinear systems algebraically. So what we're going to do today, the warm-up, is coming up with 3 different ways of solving quadratics and then using any of those 3 methods to solve the following. So we have several methods of solving quadratics. One of them is the quadratic formula, and that one will work every time on every quadratic. It just sometimes you need zeros in places, and that is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. We also have factoring and zero product property. And we'll do a short kind of tutorial, not zero property. Sorry about that. Zero product property. There's also completing the square and isolating x. That one is not particularly helpful with a problem like we have in front of us. I'll explain why. This particular problem has a 3 for our leading coefficient, and we can't factor out a greatest common factor of 3, so completing the square is not really an option in this one, or at least not a very good option. I'm going to go ahead and do quadratic formula with this one. If you are comfortable with quadratic formula and zero product property, you can skip towards the end of this video to get to the solving systems of quadratics algebraically. You can skip to those notes because the first part of the video is going to be really just reviewing how to solve quadratics, because I know that's a struggle for a lot of people. So the quadratic formula assumes the the form ax squared plus bx plus c equals 0. So we're looking at the terms in front of x squared and x and then the constant. So in this case, a equals 3, b equals negative 14, and c equals negative 5. So I plug all those in to my quadratic formula over here, and I need to be really careful with the negatives. There is a negative in this formula, and b is also negative. So I need to make sure that when I plug everything in, it's all plugged in with the negatives in place. So that's going to be x equals negative 14 plus or minus the square root, parentheses, negative 14 squared minus 4 times 3 times negative 5, all divided by 2 times 3. So when I simplify this, what I'm going to do is I'm going to take this part under, wrong color, sorry, under the square root sign, all that, and I'll remove that in a second, and I'm going to plop that into my calculator. And what I get when I do that is I'm going to reduce this negative 14, so I'm going to put that as a positive 14, plus or minus the square root of 136 divided by 6. Now when I actually take the square root of 136, I'm not going to get a whole number. I get 11.6619, blah, 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 blah. So what I'm going to do is I'm going to round that off. I'm going to put it down below. So I have 14 plus or minus 11.66. These don't always come out to whole numbers. This would also indicate this particular quadratic is not going to be Yes, it is 2-factor rule. I did something wrong. Hang on. Okay, I figured it out. Back here at the 136, because I was not using my graphing calculator, that is not 136. What I had done to get the 136 was I had taken negative 14 squared, which is 196, and I had subtracted 4 times 3 times 5, and I had neglected that double negative. So this should have actually been negative 14 squared plus 60, which would have given me 256, which does have a whole number. Sorry about that. So that whole number is 16. So the square root of 256 is 16. And then all divided by 6. So as I was saying before, sometimes the quadratics don't come out to whole numbers. This one does. So then I split this off, actually, into a plus and a minus. So 14 plus 16 divided by 6 gives us 30 divided by 6, which gives us 5 for one of our answers. The other one, 14 minus 16 divided by 6 gives us a negative 2 divided by 6. That ends up being a decimal of 0.3 repeating. So I'm just going to reduce that fraction to negative 1 over 3, negative 1/3. So quadratic formula, that's one method of solving. A couple things to keep in mind as we move forward with quadratics. To solve full quadratics, and I want to note that a full quadratic is like the ax squared plus bx plus c. We can't isolate x because of the x squared and the x, and that's why we need the quadratic formula or the zero product property. And in order to use either of those, everything must equal 0. So we need to have, say, 3x squared plus 8x minus 10 equals 0. Or we need to have something factored as x plus 2 times 2x minus 3. That has to be set equal to 0 to use the zero product property. The only time we can use something otherwise is when we have conditions where we can isolate x. So moving forward, if I have a problem like this one, 2x squared plus 6 equals 38, I only have x squared. I don't have an extra x there that I have to deal with, so I can actually just isolate x here. I can subtract 6, get 2x squared equals 32. I can divide both sides by 2, so I have x squared equals 16, and there I take the square root to get x equals plus or minus 4. The reason for the plus or minus there is if I take 4 squared, that gives me 16. If I take negative 4 squared, that also gives me 16. So that is why we have that plus or minus. With a problem like this, I can't isolate x because I have an x squared and I have an x. I can't combine them because they're not like terms, but I also can't just get rid of them. One of the things people talked about doing in other classes was dividing everything by x, but then that leaves us with a different situation. So this particular one, we have to use a zero product property or quadratic formula. Because we can't take the steps that we took up here to isolate x. So, so to use zero product property, that means we got to factor, and what that means with this one, this right now equals 10, and we can't have it equaling 10, we have to have it equal to 0. So what we're going to do is subtract 10 from both sides. Make note that I can't subtract 5x minus 10. Those aren't like terms, so what I'm going to do instead is write this out as 2x squared plus 5x minus 10 equals 0. Give me a moment to see if this one is actually factorable. This one is not factorable, because if I look at, do this really fast and then I'll erase it, 2x squared minus 10 gives us negative 20x squared. Take the middle term, 5x. Whoops. If I factor 20, I've got 1 and 20, 2 and 10. It's not divisible by 3, and then I have 4 and 5. And then it switches back to 5 and 4. Top number is negative, which means one of my numbers has to be negative because the bottom number is positive. That means the bigger number has to be positive. None of these pairs, negative 5, 4 and 5, negative 2 and 10, negative 1 and 20, none of those add up to 5x. So this one's not factorable, which means I'm going to have to use quadratic formula. So once again, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I'm going to plug everything in there. So here my a is 2, b is 5, c is negative 10. So x equals negative 5 plus or minus. That negative, by the way, right there is from the formula. B is positive, so it needs to stay there. So I've got 5 squared minus 4 times 2 times 10, all divided by 2 times 2. So x equals negative 5 plus or minus. All right, so one of the things I just realized I forgot. This is the negative 10, so I need to put that in my formula here. So what I get when I put all of this into the calculator is the square root, didn't mean to be in red there, square root of 105, which is not going to give me a whole number. I'm going to have to round that one off. And then all divided by 4 because of the 2 times 2. So I've got negative 5 plus or minus. This ends up being 2.25 roughly, divided by 4. And then I'm going to split it off into the plus and the minus. So negative 5 plus 10.25, all divided by 4. So that's going to give me 5.25 divided by 4, which is 1.3125, approximately anyway. Then I'm going to do negative 5 minus 10.25 divided by 4. That's going to give me negative 15.25 divided by 4. Sorry, I'm running out of space down here. That's going to give me 3.8125, and I'm going to run out of space. So the next thing I need is something I can factor to show you. So I'm going to pause for a moment. Okay, so 2x squared minus 1x equals negative 15. I'm going to set that equal to 0. This is really for finding the roots and finding the factored form. On the calendar, the class calendar, I have some extensive notes on using the box and diamond to factor. I'm just going to go through the process here, try to remind you of everything. I would look at those notes and get those in your notebooks, though, because as we go through this, it's hard to figure out what goes with what and where things come in and what order you do them in. So I also have some from a while back that did the same thing. So I'm going to start with my first term here in the lower box. last term with the negative. Then I'm going to multiply those two to get my top number, negative 30 x squared. Then my bottom number, negative 1x, goes on the bottom. So what I'm looking for here for my side numbers and what will go in these two boxes are two numbers that multiply together to give me negative 30 and add together to give me negative 1. So what I'm going to do is factor 30. I'm not going to worry about the negatives yet. So 1 and 30, and 30 divided by 2 is 15, 30 divided by 3 is 10, 30 divided by 4 is not a whole number, then 30 divided by 5 is 6, and then I'm back to 6 and 5, so I know I have all of my factors. So when I have a top number that's negative, that means I have a negative times a positive. So one of these columns has to be negative. If my bottom number is negative, that means the bigger number is overtaking the smaller number, so that means the bigger number is negative. So what I'm looking for is the pair that adds up to negative 1. That pair is, hang on just a second. That pair is the negative 6 and 5, and I put those here. So negative 6x, 5x, and those also go into the remaining boxes. So then I need to come over to this. I have figured out the terms that I need. This is everything inside. I need to figure out what my factors on the outside are going to be. So I'm going to look at a greatest common factor from a row, and sorry, that was a column that I was pointing at, and a row. If I look at 5x and 2x squared, 5 and 2, the greatest common factor is 1, because 2 is not divisible by 5, 5 is not divisible by 2, but both of these have an x, so I can factor out an x. Over here on this row, 2 and negative 6 are both divisible by 2, so I can take a 2x out over here. Then I'm looking at what do I multiply 2x by to get 2x squared, so that's going to put an x right there. Then I'm looking at 5x divided by x, which gives me 5. The other way I can think about that is x times something gives me 5x, so that's going to give me 5 over here. 2x times something is going to give me negative 6. The other way to look at that, negative 6x divided by 2x is going to give me a negative 3. And lastly, I want to double check that negative 3 times 5 is going to give me a negative 15, and it does. So my factors are 2x plus 5 times x minus 3. And I'm just taking those directly from my sides. 2x plus 5, x minus 3. This all has to equal 0. So now I'm using the zero product property, and what the zero product property tells me is if I'm multiplying two factors, so this is one factor, this is the other factor, to equal 0, then one or both of those has to equal 0. So what I'm going to do is I'm going to take each one and set it equal to 0. 2x plus 5 equals 0, and x minus 3 equals 0. And then I just solve them separately. So on the 2x plus 5, I subtract 5 from both sides. So I have 2x equals negative 5. Divide both sides by 2. So I have x equals negative 5 over 2. On the other one, I add 3 to both sides. So I've got x equals 3. So that is solving using the zero product property. Finally, what we're getting to today is how do we use that to solve quadratic equations and systems algebraically. So if we look at the top here, if we just have an x term, which we've talked about already, then we can just isolate x. So I can add 14, x squared, equals 25, square root both sides, so I've got x equals plus or minus 5. That's when you can isolate x. If you can't, then you have to get everything equaling 0. On this first one, I'm looking at I want this side to be 0, so I have to get rid of all that stuff. So I'm going to subtract the 5x. I'm going to put it under the negative 10x, because that's where I'm going to take it away, and then I'm going to subtract the 7. So what I have here, 3x squared minus 15x equals 0. I can solve this a couple different ways. I can use zero product property. I can use quadratic formula using a c value of 0. I'm going to just go ahead and factor out a greatest common factor. Both 3x squared and negative 15 are divisible by 3, so I can pull that 3 and the x, because they both have an x out front. So 3 times x is going to give me 3x squared. So I got my x there. And then 3 times negative 5 is going to give me negative 15x. So minus 5 equals 0. Set both parts equal to 0, because now I have a factor of 3x and x minus 5. Those are my two factors, so I'm in zero product property mode. So 3x equals 0. Divide by 3, so x equals 0 for one of my answers. X minus 5 equals 0. Add 5, so x equals 5. So those are my two answers. And I would have gotten that if I did zero product property using the box and diamond, which is not necessary, or if I had done quadratic formula. On the next one, I've got two full quadratics. Again, I want to get everything over from one side to the other. I'm going to get all of the stuff on the right side to the left side because I have a negative x squared here, and I prefer not to have negative x squared, sorry. So I'm going to add x squared. I'm also going to add that here. I'm going to subtract 7x, subtract it here as well, subtract 15. So everything here adds out to 0. X squared plus x squared is 2x squared. I'm going to put that in a different number, a different color. So 2x squared, 12x minus 7x is positive 5x, and then 3 minus 15 is negative 12, and that all equals 0. So I'm going to go ahead and put that in the quadratic formula with an a of 2, b of 5, c of negative 12. So x equals negative 5 plus or minus square root 5 squared minus 4 times 2 times negative 12, all divided by 2 times 2. I'm going to pause it and put the rest of the work on here and then jump back in a moment. Okay, so having zoomed in, coming up here, I put all of this stuff in the calculator to get negative 5 plus or minus the square root of 121. Multiply 2 by 2 to get 4. Negative 5 plus or minus 11, so 11 is the square root of 121, divided by 4, and then I split it. Negative 5 plus 11 gave me 6, divided by 4. So 6 over 4, that also reduces, by the way, to 3 over 2. And then over here, negative 5 minus 11 gave me negative 16 over 4, which is negative 16 divided by 4, which is negative 4. So that gives me my two answers that way. I can also use zero product property for that. I'm going to shrink this back down, and then we're going to move it up to look at what we do with systems of equations. So when I look at this, I've got a quadratic and a linear. Both of them are set equal to y, so that means I can set them equal to each other. In other words, basically use substitution. X minus 3 is equal to y, so I'm going to put it in for that y. Let me erase that so it's not so messy. So what I have is x minus 1 squared plus 2 equals x plus 3. With the parentheses here, I have to multiply that out so I can combine things. So when I multiply that out, I'm going to swing this over here. Remember, this is x minus 1 times x minus 1. So I have x squared minus 1x minus 1x plus 1. So this gives me x squared minus 2x plus 1. And then I'm going to add it to this 2 sitting there. So x squared minus 2x plus 1, and then drop down that plus 2 from up here. That all equals x plus 3. I need everything to equal 0, so I'm going to subtract some stuff here. So minus x, minus 3, and minus 3. This part right here gives me 3 when I reduce it, when I simplify it. So I'm left with x squared minus 3x. 3 minus 3 gives me 0, so that all equals 0. I'm going to use greatest common factor again, factor out an x. I'm left with x minus 3 equals 0. Split this off using zero product property. X equals 0. X minus 3 equals 0, so x equals a positive 3. Once I have my x values, and move this again, I need to find y. So if I look at my equations up here, easiest to do that with x plus 3. I could use this one. I'm not gonna, though, mostly because this video is forever long already. So I have y equals x plus 3. I'm going to take out that x, replace it with the 0 that I have from up here. So I've got y equals 3. So what that means is one of my points of intersection is the point 0, 3. I need to do that with my other equation, y equals 3 plus 3. So y equals 6. So my other point of intersection is the point 3, 6. So I'm going to shrink this back down. A lot of it's going to go in pieces. That's obnoxious. So, there we go. So that's all in all the basics of it. Setting them equal to each other, solving it like you would a quadratic. Once you have your x's, plug them in to get your y's. And you're reporting usually 2 different points of intersection. So that is it for this particular video. If you have more questions on solving quadratics, there is a video running around somewhere of that, but I don't remember which one it was. Once I figure it out, I'll link it on the YouTube channel on this video. So anyway, sorry that got so long-winded. Have a good one.